So in our last video, we learned that we can pass from one square, like our square of 3, to the next successive square. And successive, remember, means that we're going in order. So if we're passing from the square of 3, our next successive square would be the square of 4. And then if we wanted to keep going, our next successive square would be the square of 5, and then 6, and then 7, and then all the way up to our square of 10. And we found out that we can do that, right? We can use 3 as our foundation to build 4, which means we could use 4 as a foundation to build 5, 5 as a foundation to build 6, and so on and so on. Today, we are going to actually give ourselves a new challenge, and we are going to challenge ourselves to actually skip squares and see if we can pass from one square to a non-successive square. So I'm going to skip the square of 4, and I'm going to try to make the square of 5 by starting with my square of 3. Now, remember, in the last video that we watched, we talked about how we are going to challenge ourselves to build with 3s as long as possible, because 3s are our foundation. And so we're going to keep that foundation as long as we can until we absolutely can't anymore. So I'm going to give you a second to see if you can see within our square of 5 our square of 3. Can you see where a foundation could start to be built? All right, you may have seen it somewhere else, but I always like to start with my upper left-hand corner, and I can see that my square of 3 fits right there, and there is a foundation right there. Okay, so now I need to build off of the sides, right? I need to build this way for my width, and I need to build this way for my length down. Well, I guess this would be width and this would be length. Either way. Okay, so I know I have 3, but I need 1, 2, 3, 4, 5 going down. 1, 2, 3. So I'm going to grab 3s. 4, 5. Okay, so now my length going down is 1, 2, 3, 4, 5, which is perfect. Now, to get a perfect square of 5, I also need 5 going my width. 1, 2, 3. I need 2 more here, 4, 5. And I'm going to build those using my 3s. 4, 5. So it looks like if I just count my length and width, I have 5 by 5, but it's not fully there yet because we still have this section, this one little corner. And I can't use 3s for that, right? They're not going to fit. If I were to transpose it onto our blue square, here's this. And these ones aren't going to quite fit because of our bars, but if they did, we can see, I would have them here, and I would have another one here. And so if we look and see what blue is left over, we can see 1, 2, 3, 4 little beads right in that bottom corner. Now, we don't have, and it's a perfect square. Look at that. So we actually don't have 4 in a little square, but we do have ways to make that. So I could either use 4 of my red units, but I'm not going to. I'm actually going, it's much faster if I use my 2s. So I'm going to use 2 and 2 to take up that 4. Now, I'm just going to double check. I know that a square of 5 is 5 by 5, or 5 squared, which is 25. So this should also be 25 if we passed from the square to a square of 5 correctly. So I know that I'm trying to get to 25. So let's see. I have 9 here, because 3 squared is 9. And then I have 6, so 9 and 6 is 15, right? Yeah. And then I have 6 more, and 15 plus 6 more is 21, and 21 plus 4 is also 25. We did it. Now, let's look at this mathematically, because I just checked by actually counting up my beads, but let's look at this in a mathematical equation. I'm actually going to tilt this down so you can see it hopefully a little bit better. So I always like to go by the order in which I started building. So I started with my with 3 squared. So I started with 3 squared, and then I added on. And the next thing that I added on was my length and my width, but I still used 3s. And I actually added it on, so I had 3 taken 2 times, right? But then I had another set of 3 taken 2 times. So I could say that I had 2 sets of 3 taken 2 times, right there. And then I added on a 2 square, really, because 2 squared, I made a perfect square, and 2 squared is 4. And that equaled 25. Let's try one more. Okay, so let's say that I wanted to pass from a square of 6 to a square of 9. And I'm going to challenge myself to build with 6s as long as possible because 6 is going to act as my foundation. So I always like to start in my upper left-hand corner. And I can see that if I put my square right here, I have a foundation. So I already have 6 by 6, but I now need my length down to be 9, and I need my width across to be 9. So I'm going to start building off of those sides. So I need 1, that'd be 7, that'd be 8, that would be 9. Let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, I have my length of 9. And now I need 9 this way, so I'm going to use my 6s. 1, 2, 3. If I squish them over, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that worked. Okay, now we have some missing down here. So I think I'm not even going to move them over here. Here's what I notice. I have 1, 2, 3, 4, 5, 6. I need 7, 8, 9. I need 3 more. That means I should need 3 more this way as well, right? 1, 2, 3, 4, 5, 6. I need 7, 8, 9. I need 3 this way as well. So I need a 3 by 3. A 3 by 3 would be a perfect square. And you know what? I actually do have a perfect square. Right here. So now if I were to count, I should have a 9, whoop, sorry guys. I should have a 9 by 9. So I know I have 9 this way, and now I have 6, 7, 8, 9, perfect. And then I have 9 by 9. We totally did it. Now, I know that 9 squared is 9 times 9, which is 81. And we're just going to do some mental math really fast and double check and see if we also got 81 here. So I know 6 by 6 is 36. And then I have, let's see, I have 18 here and 18 here. 18 and 18 is also 36. So 36 and 36 would be 72. And 72 plus 9 would totally get me to 81. Now, let's look at this again in mathematical terms rather than just doing it mentally. Let's put it down on paper. So we can see that we started with 6 squared, and then we added on 2 sets of something. So I'm going to say we have 2 sets, and we had 6 taken 1, 2, 3 times. So 2 sets of 6 taken 3 times, and then we added on 3 squared. And that got us to 81. And we could even go one step further, and we could just quickly double check it. We could say 6 squared is 36. 6 times 3 is 18, taken 2 times, that would be 36. And 3 squared is 9. And we already did that mentally, and we figured out that actually did equal 81. I hope you can see this. I have a feeling you might not be able to. And there we have it. Now I'm going to do something. I'm going to lay out all of our past problems that we've had that had to do with passing from one square to another. Some of them were successive, some of them were not. And I'm going to just kind of give this to you to see if you can find any connections between them, if you notice anything that's similar or anything that changes every time, any patterns that you notice. So as you're looking at this, I'd like you just to see, so this is going from a 3 to a 4, and here's our equation. Here's going from a square of 4 to a square of 5. Here's our equation. Square of 3 to a square of 5, our equation. And a square of 6 to a square of 9, and here's our equation. So what I'd like you to do is just kind of look and see if you notice any connections between the squares and the numbers. Any relationships that you see, and relationships really in math are just ways in which different numbers are connected. Do you notice any patterns or relationships that hold true throughout all of our equations? Maybe looking at what it was always started with. What's something that never seems to change no matter what when we're going from one square to another? What's the layout of the equation? And if you see some relationships, if you see patterns, can you come up with a math truth that you could say seems to always hold true when you're passing from one square to another? Something that you could maybe test out for yourself.